We take a deep breath. It's going to take a little while. Test our resolve and our focus. We have x minus 3 for the 3. We have x minus 4 plus 2i, and I put that in parentheses because I always subtract the root. And if I have 4 plus 2i, I also have 4 minus 2i, right? Because if you look up here, the complex conjugates, if I have a plus bi, then I have a minus bi. Okay, so I also have x minus 4 minus 2i. Okay, and I'll just do this first. So, in fact, I think I'll just do this part first. So what do I get? I get x squared, because x times x, right? X times x, okay. Then, I guess, you know what's going to happen here. I'm going to get negative 4 and negative 2i, and I'm going to get negative 4 and positive 2i. So the 2i's are not going to come out of the middle term. They're conjugates, and they're going to disappear. However, the 4 is negative both times, and I'm going to multiply by x both times, so I'm going to get negative 8x. Okay? And then let me do something off to the side, because now I have to multiply these two last terms together. So I'm going to say 4 plus 2i times 4 minus 2i, and see what I get there. I'm going to get 16, 4 times 4. I know that my middle term isn't going to count because they're conjugates, and then I'm going to have negative 2, positive 2i times negative 2i is negative 4i squared. 2 times 2 is 4, and I times I is I squared. I squared is another way of saying negative 1, so I'm going to say 16 minus 4 times a negative 1. Well, that's going to be plus 4, so it's going to be 20, so I'm going to say plus 20. Okay, so that's what happens with all of that. And I have x minus 3 out in front, and I suppose I'll go ahead and do that. I have x to the 4th, because I'm doing this, okay? And then I'm saying x to the squared. Wait, x to the 4th, where'd that come from? It's not x to the 4th yet. It's x to the 3rd. Now it's going to be minus 8x times x is x squared. And 20 times x is 20x. Then I'll do the next line. I'm going to say negative 3 times x squared. And so I have negative 3x squared. Negative 3 times negative 8x. And so I'm going to have positive 24x. And negative 3 times 20 is negative 60. If I put these together, I'm going to get x to the 3rd minus 11x squared plus 44x. Not minus 60. Now, the other part here. Let me go back up here, and I say if I have 1 plus the square root of 7, I also have 1 minus the square root of 7. Okay, because conjugates. If I have, a minus the square root of b, then I also have a plus the square root of b, and vice versa. So, I know that I'm going to say x, take away my root, which is 1 plus the square root of 7. And I'm also going to have x take away my root, which is 1 minus the square root of 7. Alright, I'm going to multiply that out. I'm going to get x times x is x squared. Once again, I'm going to say negative 1, negative square root of 7, negative 1, positive square root of 7 if I distribute the negative. And I'm going to multiply x by negative, here I'm going to say x times negative 1 and x times positive square root of 7. But over here, on the first one, I'm going to say x times negative 1 and x times negative 7. Well, the negative 7 part's going to go away because one was positive and one was negative. So I'm going to ignore, for the middle term, I'm going to ignore the middle. I'm going to ignore the square root of 7. And I'm just going to focus on the fact that both times it was x times minus 1. So if that happens twice, I get minus 2x. And then the last part, well, let me take this over to the side like I did before. 1 plus the square root of 7 times 1 minus the square root of 7. There will be no middle term because these are conjugates. I have 1 times 1 is 1, and I have the square root of 7 times the square root of 7 negative is negative 7. So that's a negative 6. So I'm going to come over here and write negative 6. All right, and that is what I get when I multiply that out. So now I'm going to say this that I had already times this that I just found. And once we multiply that out, we will have our 5th degree polynomial. Least degree. The least thing I could get was, I suppose I should do it like this. The least had 1, 2, 3, 4, 5 roots. So I know it's 5th degree. That's the least I could do. Can't do, don't want to do more, can't do less. Alright, so let's methodically take x to the third times each one of these. Okay, each one of, that's what I'm going to do for every term in the first with every term in the second. So I have x to the 5th minus 2 times x to the 4th and minus 6x to the 3rd. Now I'm going to do it with this guy. Have him multiplied by each one of these, okay? So methodically go through here. We have x squared times x squared. That's x to the 4th, and a negative 11 comes along. Negative 11, positive 2, that's plus 22, x to the 3rd. And negative times the negative is plus 66, x squared. The next one, I was going to say the last one, but there's 4 up here, so I have to do this 4 times. 4 things times 3 things. It's going to take a little while. So 44 times 1 is 44, x to the 3rd, x squared times x. 44 times 2, negative 2 is negative 88, x squared. 44 times negative 6. So I'm going to grab my calculator for that, because I don't trust myself. 264, and it's going to be negative 264. And the next did come along. Okay, so finally, negative 60. Negative 60 times x squared. Negative 60 times negative 2 is plus 120x. And negative 60 times negative 6 is positive 360. And I will add these up, and I will get my answer. X to the 5th. That wasn't too bad. Negative 13, x to the 4th. This was a positive, right? Yes. So I have 66, take away 6 is 60. X to the 3rd. I said x squared, but I was wrong. X to the 3rd. And then let's see. Negative 60, positive 66, that's a positive 6. And then a negative 88 means I have negative 82, x squared. I think that's how that works. Seems like it. And I have negative, okay, so I'm just going to subtract and it'll be negative. So I have 144x plus 160. And I just kind of looked over to see if there's anything I could factor out of all these, and there's not. For one thing, I don't have anything but a 1 out in front. Is that what they wanted? I think that's what they wanted. With a leading coefficient of 1, yes. And rational coefficients. Yes, these coefficients are all rational. Very rational. Okay. No square roots of 3s or anything like that. Alright, that's my polynomial, and I know what the roots are. The roots are all up here. These are all the roots. Alright. I started with that. I went the other direction this time.